In this lesson, I'm having students look at applications of exponential functions, and we're applying Newton's law of cooling to time of death, how to determine time of death based off of the temperature of the body. And so we first start off, the coroner arrives on the scene and takes 2 readings. The first initial reading she takes is right when she arrives at 10 p.m. So at time 0, it's 92.4 degrees Fahrenheit. And this is in minutes, because 30 minutes later, time is in minutes. 30 minutes later, she takes another reading after she does the work that she needs to do when she gets there, and it is 91.8 degrees Fahrenheit. So I used those 2 temperature readings and substituted in for T of T is the temperature at time 30, and then the initial temperature when she got there at 10 p.m. was 92.4. And so when I solve for K, we go through and solve for K. K is going to be approximately equal to 0.008. 0008. And so that's going to be 8/10,000ths. And so they're going to use that for that rate of change. And we're going to have to do another problem to determine time of death. So this time we're going to use the actual temperature of the body, which should have been 98.6 for a normal temperature. We're going to assume it was normal. For initial temperature at time of death, still subtract the 68 degrees room temperature shown on the thermostat. So the 68 will stay the same. The only thing changing is the initial temperature will be 98.6 at time of death, and the other one is going to be 92.4. We know was at 10 p.m. So when we actually solve for lowercase t for the time of death that has passed, we have to count backwards from 10 o'clock or 10 p.m. So that's going to be negative 0.0008, and we're solving for lowercase t for the time that we have to count backwards from 10 p.m. And so then when we have subtract 68 from both sides, we end up with 24.4 is equal to 98.6 subtract 68, that's going to be 30.6, and you still have e to the power 0.0008 times that t, and then when you divide by 30.6, you're going to get e to the 0.0008 t. Where is that? 8/10,000ths times t is equal to 24.4 divided by 30.6 was 0.80. And then when you take the natural log of both sides, you get, so I take the natural log for the inverse of e, I'm going to get t is equal to negative 0.223 divided by negative 0.0008, and so t is approximately going to be equal to 278.75 minutes. And we need to change that back to hours and count backwards from 10 p.m. Well, 240 minutes would be 4 hours, 4 times 60. So you're going to have to count backwards 4 hours, 38 minutes, and then we have to do 75 hundredths of 60 minutes. So that's going to simplify to 6 over 10, which would simplify also to 3 over 5. And then 5 divides into 75 15 times, so it's actually going to be 45 seconds of that minute. So you're going to have 4 hours, 38 minutes, and 45 seconds that I have to count backwards from 10 o'clock to find the time of death. And so that would have been 4 hours back would have been 6 p.m. Subtract 38 minutes off of that hour, it would have been 5:22. And then 45 seconds off of that would have been 5:21 and 15 seconds. So 5:21 and 15 seconds PM is the time of death.